Welcome to Intro to Triangles Day 1. Today you'll be doing a warm-up, we'll go over some notes, and then you will have a chance to practice on different types of triangles. First, let's start with our warm-up. Number 1 and 2, we're asked to classify each angle. Angle A measures 113 degrees. That would make it an obtuse angle. Angle B measures 27 degrees. That would make it an acute angle. By the way, you should be doing this warm-up before you start the notes and just checking your answers here. Number 3 asks us to solve the equation 12x minus 10 equals 4x plus 6. If we add 10 to both sides, we'll get 12x equals 4x plus 16. Subtracting 4x would then give us 8x equals 16. And if we divide both sides by 8, we should get x equals 2. You can always plug back in to check. Here, x plus 2 equals 2x minus 5. I will subtract x from both sides to keep my variable positive, which will leave me with 2 equals x minus 5. Then adding 5 to both sides gives you 7 equals x. Again, you can always plug in and check. Number 5 is asking us to find the midpoint of segment PQ. Point P being at 7, 3, point Q being at 4, 9. Hopefully remember we're going to add the x coordinates, divide by 2, add the y coordinates and divide by 2, which would give us a midpoint of 11 halves, 6. And for number 6, if P is at negative 2, 8, and Q is at 0, 6, and we find the midpoint of that segment, we would get negative 1, 7. Now into some new things. Today we're going to be talking about the triangle sum theorem. But first we need to classify triangles by sides. There's some new vocabulary here. Make sure, however you learn your vocabulary, you take care of this. First type of triangle we're going to talk about is a scalene triangle. This is an example of a scalene triangle. The properties of a scalene triangle is that there are no sides congruent. Notice the sides here are lengths of 9, 13, and 14. Next type we have is an isosceles triangle. Most of the time you'll see an isosceles triangle with 2 congruent sides, but note the definition is that an isosceles triangle has at least 2 sides congruent. The third is an equilateral triangle. An equilateral triangle is a side that has all 3 sides congruent. We can also classify triangles by their angles. An acute triangle, for example, has 3 acute angles. A right triangle will have 1 right angle in it. An obtuse triangle, which might look like this, is going to have 1 obtuse angle. The other 2 would have to be acute. An equiangular triangle is going to have 3 equal angles or 3 congruent angles. We can classify triangles by both names. For example, you could have a scalene right triangle, which would mean it would have 1 right angle but all 3 sides of different lengths. You can have, well, the only exception is if you have an equilateral triangle, it will always be equiangular. An equiangular triangle will always be equilateral. Here's an example. We want to look at this triangle PQO. We want to classify it by its sides, then determine if the triangle is a right triangle. Well, how can we do that, you ask? First thing we're going to have to do is do the distance formula 3 times to find out the length of these 3 sides. If you do that, and I went here and did it for you, you'll find that the length of PQ is 7.07, the length of PO is 2.34, and the length of OQ is 6.71. As we can see, those 3 are different numbers, making triangle PQO a scalene triangle. Next thing it asks us to do is determine if it's a right triangle. Now we know if it's a right triangle, it's got to have a right angle in it. The way to see if this is a right angle, it looks like it could be, but let's figure it out. We need to figure out the slope of PO and the slope of OQ. I went ahead and did that. The slope of PO is negative 2 because we're going down 2, right 1. The slope of OQ is 1/2 because we go up 1 over 2. Those are opposite reciprocals, so they're perpendicular. If they're perpendicular, that forms a right angle. So triangle PQO is a right triangle. More specifically, it is a scalene right triangle. The triangle sum theorem tells us the sum of the interior angles of a triangle add up to 180 degrees. So in this triangle, angle A plus angle B plus angle C equals 180 degrees. This is extremely important. Remember it. It will come into play throughout the rest of the school year. The exterior angle theorem tells us the measure of an exterior angle is equal to the sum of the two non-adjacent interior angles. You're probably going, huh? Basically what it tells us over here is that angle 1, which is the exterior angle here, is equal to the sum of angle A plus angle B. Again, this is very important. You're going to have to remember it. Here's an example for us. We know that angle J is x degrees, angle L is 70 degrees, and angle JKM is 2x minus 5. So we're going to use the exterior angle theorem because we have the exterior angle, which tells us that 2x minus 5 is going to equal x plus 70. If we subtract x over, we'll get x minus 5 equals 70, and then we add 5, we get x equals 75. Make sense? I hope so. Here we've got triangle with an angle measure of 40 degrees, an angle measure of 3x degrees, and then we've got an exterior angle here that's 5x minus 10. We know the exterior angle should equal the sum of the two non-adjacent interior angles. So what that means is that 5x minus 10 is going to equal 3x plus 40. Subtract over the 3x, 2x minus 10 equals 40. Add 10, 2x equals 50. And divide by 2, x equals 25. That's great, but it asks us to find the measure of angle 1. So we have to plug x in to the exterior angle. So we have 5 times 25 minus 10, which is a 115 degree angle. Hopefully we know that this exterior angle and angle 1 are a linear pair, which means they're supplementary. So since those two are supplementary, I can just take 180, subtract 115, and that'll give me 65 degrees as the measure of angle 1. I also could have plugged the 25 in for the 3x and done 3x plus 40, or 3 times 25, which is 75, plus 40 plus the measure of angle 1 equals 180. Another theorem we have that is helpful, but it's not as important, is the corollary to the triangle sum theorem, which tells us the acute angles of a right triangle are complementary. Basically what that says is since this is 90 and the whole thing has to add up to 180, these two have to add up to 90. Makes things quicker, but you could always add all three of them and set it equal to 180. But it asks us here to find the measure of the acute angles. So using that corollary, it tells us that 2x plus x minus 6 equals 90. We combine like terms, 3x minus 6 equals 90. Add 6, we get 3x equals 96, and then x equals 32. Of course, we're not done because it says to find the measures of the acute angles. So we're going to plug 32 in for x in the 2x and get a 64. And if we plug 32 in for x here, we get 26 degrees. So those are the two acute angle measurements in that triangle. Number 5, we're just going to go good old-fashioned triangle sum theorem here. The sum of the three angles should equal 180 degrees. So 2x plus 4 plus 3x minus 5 plus 2x minus 1 equals 180 degrees. If we combine like terms, 7x minus 2 equals 180 degrees. Add 2 to both sides, you get 7x equals 182. Divide by 7, and you get x equals 26. Here we were just asked to find the value of x, so that's all we need to do there. If you were asked to find the angle measurements, you would take your 26, plug it back in for x in all three of those angles, and you can then figure out the angles in the triangle. Hope you enjoyed the notes. Feel free to watch again. Have a great day.